It is so nice to be here with you today. I'm first time in Bangalore, and I have really good impressions about the people in particular. So let's start. Let's start with ClickHouse history. ClickHouse started as a prototype in 2009. How many years was it ago? Not 20 years, but more than 10 years. So after 9 years in 2016, I made the decision to make ClickHouse open source under Apache 2.0 license. And probably this was one of the most important decisions in my life. Because after that, ClickHouse usage just exploded all over the world. Many companies started using ClickHouse, started providing feedback, providing contributions. We made hundreds of releases during that time. And in August 2021, we decided to make a company with the goal to provide the best service for the best analytical database. We founded ClickHouse Inc. with our investors, like the biggest investors, Index Ventures and Benchmark Capital. And in just about a year, we launched the first version of our product in AWS in 2022. Then we launched it in GCP and in Azure. And then we provided it in BYOC form, bring your own cloud. Now we have full feature product to serve your needs. And this year, we are organizing our first conference, first in San Francisco, then Sydney, Bangalore, Amsterdam, New York, and here we are. ClickHouse is the fastest growing database. If we compare with databases like Mongo, but why should we compare ClickHouse with Mongo? We should not. But anyway, ClickHouse is faster. It is also faster growing. Take any database and you will see ClickHouse is growing faster. Today it has 40,000, actually 43,000 of stars. But more importantly, it has more than 1,500 of contributors, including external contributors like you. Interesting, if there is anyone who contributed at least one line of code in ClickHouse repository, one, who else? Please don't be shy. What do you contribute? Just in case. I would like to know. Congratulations. Just 1 week ago, it was merged. Congratulations. You are among the best people, ClickHouse contributors. Let's look at our customers. And today we have more than 2,000 of paying customers from many different industries, different areas, starting with small startups, continuing with largest AI companies, largest banks in the world, gaming companies, streaming and broadcasting companies, ride sharing, advertisement, many different customers. And thanks to our customers, we are improving the product. Our customers help us to make the product more reliable, more efficient, more feature complete. And this is reflected on this graph, the total storage under management. This is about compressed data size. And if we took this data size, today it is more than 30 petabytes. Just compressed data. If we take uncompressed data, it will be probably half an exabyte, which is quite impressive. And this growth is accelerating. The service, ClickHouse Cloud, is presented in every part of the world, in every continent, including India, including Australia, South America, Africa, and obviously in the United States, in Europe, in Japan, and many places in Southeast Asia. Probably we don't cover Antarctica. But if you have the needs for a data center there, maybe we can make it. Just tell us. And the same about the company itself. Today we have about 350 employees. I still say that ClickHouse is a small startup, and it is. Everyone works like in a fast-growing company to quickly adapt for all your needs. And we are fully remote with employees all over the world, also including the United States, Europe. We have a large team here in India and in many places in Southeast Asia as well. We actually have 15% of employees in APAC region. So to summarize, what is ClickHouse? It's an open source, column-oriented OLAP database for blazing fast, real-time analytics on massive volumes of data. And how is it possible? What are the key features of ClickHouse? It is a SQL database. It's not like Mongo, it's a real SQL database, and I'm proud of that. But it looks like a normal database, but with superpowers. It supports very fast data processing and very efficient compression. At the same time, it is also easily scalable to any data volumes. There are companies using ClickHouse on thousands of machines. But please don't worry. You can use ClickHouse on just a single laptop. You can use open source ClickHouse. You don't just, you take a binary and it works. It works on a laptop. It works on Raspberry Pi, everywhere. About use cases. There are 4 categories, like main categories for ClickHouse. The first category is real-time analytics. What is it? It is when you have the data constantly arriving, inserted into your database, and at the same time, you serve customer queries from applications, from people using these applications in real time with low latency, sub-second latency, sub-100 millisecond latency, tens of milliseconds for interactive analytical queries. And these queries come to ClickHouse directly and being served and returned to the customers. Another interesting scenario, another interesting use case is data lakes and data warehouse. It is for business intelligence. When the users that use the database are internal users of your company, and they want to do complex queries, ad hoc queries, or even queries with a natural language, or they use business intelligence systems like Tableau, Power BI, Superset Metabase to query ClickHouse. And often they have a lot of different data sources that they have to integrate, like Iceberg, Parquet, external databases like Postgres. And ClickHouse also does it well. ClickHouse also probably the best solution for this use case. Another use case could be particularly challenging due to data volumes. Observability. It's about logs, metrics, traces, APM, session replay, everything. And we have everything to serve this use case. Our open telemetry collector, our integrations to observability UIs, and we even have our own product, which I will present just in a minute. And what is important that ClickHouse is able to serve observability on a massive scale, on an extreme scale. If we took companies like OpenAI, Anthropic, XAI, and other AI companies, all of them are using ClickHouse for observability. Some of them are processing tens of petabytes of data every day. And another use case that is the most fashionable, the most trendy, it is about AI, generative AI. And ClickHouse serves like a foundational component for AI applications. Sometimes it is used as a vector, a system for vector search. Sometimes it is used for observability. Sometimes it is used as a backend for AI agents, for agentic analytics. And you'll hear more about these use cases today. Let's take a look at these scenarios in more detail. Observability, Lakehouse, the core database improvements, and improvements for AI. What do we have? Observability. Let's start with ClickStack. What is ClickStack? ClickStack is a full-featured observability product on top of ClickHouse. It is consisted of the core component, ClickHouse database, ClickHouse itself, which is the best database for observability. It consists of HyperDX, which is very nice and probably also the best UI for observability for logs, metrics, and traces, session replay, performance monitoring, and OpenTelemetry. All of these components are open source. We took them together and created a product that is named ClickStack. And the motivation is that like large companies, digital native companies, are already building observability products on top of ClickHouse, internal products, on a massive scale. But we want to make it available for everyone. And let me ask just a few questions. What is the best existing database for logs? ClickHouse, exactly. I wanted to give you a hint by that this database name starts with click and ends with house. What is the best database for metrics? ClickHouse, you are exactly right. Now, another question. What is the best database for traces? ClickHouse. It was so easy. So ClickHouse is the best database for observability, for every kind of observability, and we are building ClickStack on top of this, on top of ClickHouse. And we have a lot of things ahead, like the support for PromQL. So you can send your PromQL queries directly to ClickHouse database or indirectly through the HyperDX UI, and it will be able to serve them. Or another interesting thing is the usage of inverted index, text index for navigation on top of logs, for searching inside logs, or anomaly detection, alerts inside ClickStack, Terraform provider, a lot of interesting things. You will hear more about HyperDX, about ClickStack during sessions today. Now, what about Lakehouse? About data formats like Iceberg, Delta Lake, about data catalogs. And first, we have to mention that ClickHouse already has its own native format, merge tree. And supposedly it is better than like Iceberg, Delta Lake. It supports a lot of interesting things. It has the best query performance on low latency queries. It supports frequent inserts, projections, materialized views, a lot of interesting data types, like the JSON data type for semi-structured data. It is self-contained, so it requires ClickHouse and nothing else. But actually, ClickHouse is much more than just merge tree. It supports integrations, integration table engines. And it supports streaming engines like Kafka, Redpanda. It supports querying external databases like Postgres, MySQL, MongoDB, Redis. So you can create tables in ClickHouse that will just look in Postgres, or you can import data from Postgres, or you can use ClickPipes to do change data capture from Postgres, from MySQL, and from MongoDB. But also ClickHouse supports integration with open interoperable data formats like Iceberg and Delta Lake. And it supports querying single tables and attaching data catalogs. So if you have a data catalog like Unity, Glue, REST catalog, Polaris catalog, just attach it into ClickHouse and you can query merge tree tables and iceberg tables and Delta Lake tables in the same query in different queries, or you can insert data or you can export data into iceberg. It is also available. So now ClickHouse is also a table engine and very solid query engine for open table formats. And let's just compare what have we done during just last half a year. If we compare the version 24.11 and version 25.5 of ClickHouse, and we compare the capabilities for Iceberg, we can see that in 24.11 we did not have anything among these features, like support for partition pruning, schema evolution, statistics, caching of external data, time travel, introspection, support for catalogs. Now, since 25.5, we have everything. Everything is ready for you to use ClickHouse with Iceberg. And the same for Delta Lake. Catalogs, partition pruning, schema evolution, library integrations, everything is available. Everything is ready in open source in ClickHouse Cloud as well. What is next? Actually, we have a lot of things to do. Like recently, in version 25.8, we introduced our new Parquet reader. And Parquet is used as a data format inside Iceberg, inside Delta Lake. So all your queries will become magically better. We still have to implement Iceberg v3. It's a new version of data format, and it is still being developed, not only by us, also by Databricks. They are implementing many details. Change data capture from Iceberg to ClickHouse. It is probably one of the next thing and probably one of the most important things to accelerate queries on top of data lakes. Okay, what about improvements inside ClickHouse server? And the first thing is particularly interesting for ad hoc queries. ClickHouse now supports fast joins. Thank you. You might have heard a lot of misconceptions, a lot of experience from older ClickHouse versions that you can do joins in ClickHouse, but sometimes they are not fast enough. Sometimes we don't have enough optimizations for joins. We did not have cost-based optimizations. We did not have joins reordering, and it was true. But now in the latest ClickHouse versions, it is not true anymore, and we do have support. Let me uncover. So we support all kinds of joins: inner join, left, right, full outer join, and special kind as-of join. In many different variants: all, any, semi, anti-join, equi and non-equi joins, hash-based join algorithm, merge join algorithm, direct algorithm, in-memory joins, and joins with using external storage on disk. And many of these algorithms are now much faster. Let me show just a single example. Parallel hash join. So until recently, the join was parallelized only when you do lookups, but not when you build the data structure. Now everything is parallelized. The data is split into different execution lanes, and all of these lanes are processed in parallel. So now joins scale much better. What about join reordering? We can say that if you have an inner join, it's easy to just swap the tables if needed. If we have left join, just replace it with the right join and swap the tables. It's easy. but it actually is not easy because it depends how do you estimate when you have to swap the tables? How do you estimate the data volume that will be read after filters, after using indexes and after using other filters? How do you estimate if it will even worth it? And this becomes much harder when you have many different tables, like tens of different tables or even hundreds of different tables with all sorts of joins, subqueries, and we have to optimize it, not you. The goal is to minimize the latency to improve cache efficiency. And now we have join reordering. And we can even do join reordering with many tables. We can even do it with statistics. ClickHouse will dynamically choose the join order and optimize query for the most optimal. And the point is when you have like the complexity of this operation grows exponentially. When you have 10 different tables, the complexity will be like 2 in the power of 10. It could be difficult, but we have made it. Now we have global join reordering. And it requires a full rewrite of the join infrastructure in ClickHouse. And you see it will be released soon. Actually, it is already released in the release 25.9. So you can use it today. Okay, another interesting statement. ClickHouse does support updates and deletes. Actually, it already supported updates and deletes, but what is the difference? The difference is that until recently, when you run an update or delete statement, it requires a full data rewrite. Or for the case of updates, full rewrite of a certain columns, updated columns. You have to wait when this operation will be done. This operation could block merges, background merges. And the latency of this operation could be relatively high. Actually, it could be arbitrarily high. So the first thing that we have made, like half a year ago or even earlier, is the introduction of lightweight deletes. With lightweight deletes, ClickHouse no longer rewrites full data part. It just creates a deletion vector, deletion mask. It could be much lighter. It just contains the positions where the data was deleted. But this is not enough. We also need lightweight updates. And the first thing that we did, we introduced lightweight updates version 1 with remembering the expression for update. So the expression, we do nothing on the update time, just remember the expression and apply it on the select time. So it does not block merges anymore, but the problem, it slows down selects. And now we have lightweight updates version 2, the final version. What does it do? It creates, instead of updating data, it creates patch parts containing the positions, the keys of data that will be updated and the new records. And the performance of lightweight updates is as fast as inserts. You can do this operation as frequently as you can do inserts. Let's take a look. How does it compare? On this chart and in this table, you see the comparison of the update itself. The difference between full data rewrite, full columns rewrite, and patch parts is 23 times. I would say this difference could be arbitrarily high because full rewrite, its latency depends on the amount of data. Now let's take a look at the select comparison after updating. How difficult it is to apply patch data parts. And we can see the baseline is when data is fully rewritten, fully prepared. Then at the bottom, we see application of expressions on the fly, and in the middle, patch parts. And the overhead is just 20%. So you pay only 20% for any kind of updates. And this is particularly nice. Okay, so now ClickHouse has support for frequent updates and deletes. It is already available in 25.7, and you can enable it in ClickHouse Cloud in the fast channel. What about AI? AI is an interesting topic. You hear about AI from everywhere. And I'm also going to tell you a little bit about AI. ClickHouse is already proven as a foundational component for AI workloads. We have everything that is needed. We have a vector index, so ClickHouse can work as a vector store. ClickHouse is often used as a feature store. ClickHouse is often used as a data source for preparation of data sets. We also support user-defined functions to call AI models during the query. We support ClickHouse usage inside Python in process with CHDB. Now we also have a nice website, clickhouse.ai. Why? We just could not hesitate to get this domain. It is so trendy. So now we are also in trend. And on this website, you will see a lot of interesting use cases, with agentic analytics, how to build AI applications with ClickHouse as a backend. Now let's take a look at a few stories from our previous open house in San Francisco. The first story is from OpenAI. OpenAI uses ClickHouse on petabytes of logged data every day for research, chat GPT logs of API products. Basically, ClickHouse solves all the observability problems of OpenAI on Azure. Anthropic also uses ClickHouse. Like every AI company is using ClickHouse for one or another use case. And Anthropic also uses it for observability. They have a lot of security requirements, and we provide them ClickHouse to run in their trusted air-gapped environment for development of Cloud 4. So when I read the releases about Cloud 4.5, I am proud because ClickHouse is somewhere around this development. They also have huge data volumes, increased significantly during the latest launches, but they survived thanks to ClickHouse. Tesla is also a kind of AI company, but it is also an automobile company. And they use ClickHouse, guess for what? For observability. Again, they need observability for all their factory and all global operations across infrastructure behind Tesla. They have their own supercomputer for AI, and they need observability for that. They built an observability solution named Comet on top of ClickHouse. And what is interesting, they require testing ClickHouse on 1 billion records inserted per second. It was not enough. We showed that, yes, ClickHouse can insert 1 billion records per second. And they required just to leave it that for 11 days. After 11 days, they accumulated more than 1 quadrillion records. What is quadrillion? There is million, billion, trillion, and then quadrillion. I don't know what is quadrillion in crores. Probably it will be like crore of crores, right? Yeah, like that. And again, they survived and ClickHouse survived, and now they use it in production. Okay, a lot of interesting use cases, but the most interesting is to hear from local companies, from our customers.